Good afternoon, student. Welcome to the next video of artificial neural network, in which I am going to complete the new signal function, which is the sigmoidal signal function. Sigmoidal signal function, it is the most frequently used signal function in neural networks. It is given by the equation delta j of xj is equal to 1 divided by 1 plus e to the power minus lambda j xj. So this is the equation for the sigmoidal signal function. Okay. Next is, this sigmoidal signal function have two main mathematical properties, which first one is the monotonicity and second is the continuity. Monotonicity means that the function y either always increases or always decreases as x increases. Monotonicity means that the function y either always increases or always decreases as x increases. Continuity means there are no breaks in the function. Continuity means there are no breaks in the function. These intrinsic properties networks of such neurons the power of approximate and generalize on functions by learning from data. Because of these two properties, your neural network is able to approximate and generalize on functions by learning from the data. These two diagrams shows how the sigmoidal function works. First diagram, which is diagram A, is for the sigmoidal signal function for W0j is equal to 0. In this diagram, all intersection done at the 0, and it is for lambda j tends to infinity. This diagram shows what? This diagram shows lambda j tends to infinity. Okay. But and bias or w, what is the value for W0j? It is 0. The second diagram shows the shifted sigmoidal signal function for W0j is equal to minus 1. So whenever W0j is equal to minus 1, this diagram is shifted towards the right, and here at lambda j is equal to 1. Okay, so you have to remember these things about the sigmoidal signal function. Okay, how you read this diagram B? Diagram B is 0.5 signal crossing the point has shifted right to the point qj is equal to 1. What is 0.5? Here is the 0.5 where this intersection done. Okay, these are the points which you have to remember about the sigmoidal signal function. Thank you. Good afternoon, students. Welcome to the next video. In this video, I am going to cover the Gaussian signal function. The equation for the Gaussian signal function is given by, see here, delta of xj is equal to in exponential of minus xj minus cj the whole square divided by 2 sigma j square divided by to sigma j square. Okay, so this is the equation for the Gaussian signal function. In this equation, sigma j is the Gaussian spread factor and Cj is the center. Now see this diagram. Here Cj means center is 0. So you are getting the Gaussian signal function as exactly center having the exact center exactly at 0. Okay. In the next second diagram, here center is equal to 3. So what you are going to see, if we make a change in the center, then that changing the center shifts the function towards the right or left along the activation axis. So what is the activation axis? This is the activation axis. Okay, this is the activation axis. So this is the diagram for the Gaussian signal function. From this diagram, you get the idea that this the Gaussian signal function is an example of non-monotonic signal function. Why this function is a non-monotonic signal function? Because at the starting it increases from 0. Okay, at the starting it increases from 0 to its peak value. 0 to its peak value. In this diagram, the peak value is 1, and at the center, and then decreases smoothly towards the n or towards the 0 again. So this Gaussian signal function is a non-monotonic signal function. Activation close to the center of function react strong signal responses. Those far away from the center react the weak responses. जो center के पास है वो strong response देंगे, जो center के दूर है वो weak responses देंगे. There is thus a receptive field of the neuron within which they respond to inputs by generating the strong signals. These neurons can therefore be used to recognize the specific ranges of inputs. तो Gaussian signal function का use क्या होता है? If you want to recognize the specific range of input. ठीक है, I am repeating, if you want to recognize a specific range of input, in that case you have to use the Gaussian signal function. Okay, thank you.